Hello students, from today we are going to start our second chapter, that is inverse trigonometric function. This chapter is basically very less in weightage for exam point of view, but this chapter is very useful for upcoming chapter like calculus. In calculus you are going to use their several properties from this chapter. So here you need to understand about the properties of inverse trigonometric function. After that we are going to solve some questions on the basis of those properties. Okay, before starting, first we need to understand about the name of the chapter, that is inverse trigonometric function. What is function? The deep study about the function we already covered in our previous chapter, that is chapter number 1, relation and function. Here we are going to study about the trigonometric function, and we are going to find the inverse of that function. In chapter number 1 we already learned about the invertible function. When we are able to find the inverse of any trigonometric function, when the function is bijective. Only when the function is bijective. If function is 1 1 as well as on 2, then only we are able to find the inverse of that function. So here we know there are 6 trigonometric functions like sin x, cos x, tan x, cot x, sec x and cosec x. Here we need to first check these functions are 1 1 on 2. If yes, then we are going to find the inverse of these trigonometric functions. So we are going to check whether these functions are 1 1 on 2 or not. We are going with this one by one. So first we can take f of x equals to sin x, and function is defined for real to real. We learned 4 methods to check whether the function is 1 1 or not. What was the 4 method? First one is either we can take fx1 equals to fx2, then we can prove x1 equals to x2. Second method is d upon dx fx either greater than 0 or d upon dx fx less than 0. And the third method is you can plot the given equation on graph and draw the parallel line through the x-axis. If it cuts at one point, then we can say the function is 1 1. If the line cut more than 1 point, then we can say the function is manual. And the last method, that is f of minus x is not equals to fx. Well, you have to check whether the function is even or odd. These are the 4 methods on the basis of which we are going to find the function is 1 1 or odd. Okay, so now here we are going to use graphical method. We are going to plot the graph of fx equals to sin x, then we will draw a parallel line through the x-axis, and on the basis of that line, that intersection point, we can find whether the function is 1 1 or not. First we have to draw the graph of fx equals to sin x. So it could be like this: x-axis with angles at sin 0, something like this. Okay, okay, so this point is minus pi, this is minus pi by 2, this point is 0, this is pi by 2, this is pi, 3 pi by 2 and 2 pi. So here it is the sinusoidal wave for sine function. Now you need to check the function is 1 1 or not. What is the process? Just draw a parallel line through the x-axis. Here it is the x-axis. I will take another color pen. Okay. Here this line cuts at more than one point. It means the function is not one, or we can say the function is many-one function. If the function is many-one, then how could we talk about the inverse trigonometric function? Because as per the definition of invertible function, inverse function can only possible when the function is one as well as onto. Here the function is many-one, then we are not able to find the inverse. So what we can do? First we have to convert the function for which it will become 1. So what we can do? We can just crop the image on which the function will become 1. So we will crop this from this. Something like this. If we need to plot it at a different place, then we get something like this. This point is pi by 2, this point is minus pi by 2, this point is 1, and this point is minus 1. Now here you can draw any parallel line from the x-axis. It always cuts at one and only one point. So now we can say the function is 1. If we need to check the function is onto or not, then draw a parallel line through the y-axis. This is the y-axis, just draw. It cuts at 1 point, and so on. Means now we can say for minus pi by 2 to pi by 2 to minus 1 to 1, f of x equals to sine x is bijective function. For this specific region, we can say that fx equals to sine x is a bijective function. Now, if it is a bijective function, then we are able to find the inverse. Then we can say y equals to sine x, then x equals to sine inverse 1. If we have to write in terms of function, then we can write x as a gy. Gy means function g in terms of y. So it will become sine inverse y. If we have to write in terms of x, so we can write gx equals to sine inverse x. This is the invertible function. And what was the definition for this function? That is g. What the inverse function do? Just interchange domain and the range part. Here is the domain, here is the range. So it will interchange for the invertible function. So it will becomes minus pi by 2 to pi. This is the definition of the function, and this is the inverse function of sine x. Clear? Now, if we need to plot this inverse function graph, then what we can do? Okay, we could plot here for gx equals to sine inverse x. What we have done? We just simply transpose x and y. For inverse function, what we have done? We simply interchange. Means we have to prepare the mirror image for this function. How can we find the mirror image? Just draw the slope for this. Something like this. And the slope for this like this. Okay. We can do this one. This is the slope for. Now, suppose this slope work as a mirror. So, what was the mirror image for this function? It could be like this. And for this, it could be like this. If we draw in a separate plane, what we get? Something function of g. It's like this. This is like this. Okay. So here it is pi by 2, and here it becomes minus pi by 2. here it is -1, and here it is +1. So this graph is for sine inverse x. So now that's all for sine function. Now we can move further for cos. Before moving further, just pause the video to note it down. Okay, now we can move further for function real to real f of x equals to cos x. Now we need to check for the cos x. First we need to plot. Here it is 1, here it is 0, here it is this. Okay, this is -π/2, 0, π/2, pi, 3π/2, and so on. This is the graph for fx equals to cos x. Now we have to check this function is 1, 1 or not. What we can do, just plot a parallel line through the x-axis. It will cut at more than 1 point. So the function is not 1, 1. So what we can do, same process, we can simply crop the image where the function will become 1, 1. If we plot it separately, then we get something like this. Here it is 0, it is π/2, and here it becomes pi. This is 1 and this is -1. So now you can plot any parallel axis through any parallel line through the x-axis. It will cut at 1 point, it will cut at 1 point. If we need to check onto, we can draw any parallel line through the y-axis. It will cut at 1 point, it will cut at 1 point, it will cut at 1 point. Clear? Means the function is bijective at, the function is bijective at 0 to pi changes to -1 to 1, and the function is fx equals to cos x is bijective. And if the function is bijective, then we are able to find the inverse. What was the inverse? -1 to 1 changes to 0 to pi, and the function will become gx is equals to cos inverse x. Clear? If we need to plot this inverse function on xy axis, then it will be look like something. Okay, how could we draw? Just simply interchange the x and y axis. If this graph looks like this, then here it looks like something, and here we have selected 0 to pi. Just remove other part. It becomes 0 here, pi here, here it is 1, and here it is -1. So this is the graph for y equals to cos x. Y equals to cos inverse x. So please note it down. Okay, now moving further towards our third function, that is f of x equals to 10x. Now we are going to plot for the 10x. So first we have to draw the graph for fx equals to 10x. It will be look like this. Here it is -π/2, here it is π/2, 0, pi, 3π/2, 2 pi, and so on. So this is the graph for f of x equals to 10x. Similarly, if we will draw any parallel line through the x-axis, then it will cut at more than 1 point. Means the function is neither 1 1 nor odd 2. So what we can do, just simply crop one area, crop one small region. If we plot it out separately, then it could be look like this. This is pi by 2 and here it is minus pi by 2. It goes to minus infinity to plus infinity. So here, if we draw any parallel line through the x-axis, it will cut only at one point. If we will draw any parallel line through the y-axis, it will cut only at one point. Means now this function is 1 1 as well as onto. So we can write a function between minus pi by 2 to plus pi by 2 and changes to real number. Fx equals to 10x is bijective. This function is bijective. Or we can write, if we have to write the inverse, just we can simply transpose these things, so it will be like this. Then gx equals to 10 inverse x. Here, if we need to plot this function at xy axis, then simply it could be look like this. Here it goes like this, and here it goes to minus infinity to plus infinity, and here it is pi by 2 and here it is minus pi by 2. So this graph is for tan inverse x. Here one question arises, why we use this open interval? Because at minus pi by 2 and pi by 2 the value of tan function is goes to infinity. So here we can take always as a small bracket. Clear? So now again pause the video to note it down. So now we already discussed about these three, and these three are something similar like this. So you can solve this and find the graph as well. So now we are going to move towards the properties of these inverse trigonometric functions. So the first heading for the properties is self-adjusting properties. Self-adjusting properties. Now from here, the main part on which you have to focus is started now. You need to understand how these properties exist. You need to verify these properties, because in calculus there are several questions where you need to verify all these things. Okay, so you need to understand from the basic part, that how will the function comes, why it happens, and these all are based on this domain and range. We are going to calculate each and everything only between these domain and range. If any questions goes out from this range or out from this domain, then first we have to change the function between this domain and range. After that we are able to solve this inverse trigonometric function. Clear? Our first self-adjusting property is sine inverse sine theta is equals to theta, or you can write sine inverse theta is equals to theta. Similarly for cos inverse cos theta equals to theta, or you can write cos inverse theta equals to theta. Similarly for tan inverse theta is equals to theta, or tan inverse tan theta is equals to theta. Okay, we can prove as well these properties. Just take first one. Just took as a x, we get sin theta equals to sin x. On comparing, we get theta equals to x. And what was the value of x? Is this. So we can substitute sin inverse sin theta. So this is the verification of first property. See, in the same way you can solve these properties. Okay, I will solve one more. We can take cos inverse cos theta equals to x. Suppose left. Then we get cos theta equals to cos x. On comparing both sides, we get theta equals to x, and the value of x is cos inverse cos theta. So this is the verification of second property. Clear? So now we will moving further for the second type of property, that is reciprocal property. Reciprocal property is clear by its name. Like sin inverse 1 by x equals to cosec inverse x, cos inverse 1 by x equals to sec inverse x, tan inverse 1 by x equals to cot inverse x, and so on. You can write any of the property. So if we have to verify this, just let sin inverse 1 by x equals to theta. Then we can write 1 upon x equals to sin theta. Okay. Now we reciprocal this. What we get? In reciprocal of sin, we get cosec theta. If we transpose the cosec term, it will become cosec inverse x equals to theta, and the value of theta is sin inverse x. So cosec inverse x equals to sin inverse 1 by x. In the same manner, you can verify second one also. Let cos inverse 1 by x equals to theta. Then you can get the value of 1 by x equals to cos theta. If you reciprocal, then you got this, and sec inverse x is equals to theta, and the value of theta is this. So you can write and in the same manner you can simplify, you can verify the third property by yourself. Now we are moving towards the third type of the property, that is conversion property. Third one is conversion property. What is conversion? In this property, we need to convert that sine term in any other trigonometric ratio. Like we are given sine inverse x. We need to write this sine term in terms of tan or cot in any other ratio. So what we can do? Just assume this term will equals to theta. Then we get the value of x equals to sin theta. And we know very well what is sine function. Perpendicular upon base. Here perpendicular is x, base is 1. So by Pythagoras, perpendicular upon hypotenuse. So hypotenuse is 1. So with the help of Pythagoras theorem, we can find the value of base, that is square root of 1 minus x square. Now you can write any of the trigonometric ratio. Like sin theta is this. If you want to write cos theta, what is cos? Cos is perpendicular. Cos is base upon hypotenuse. So what is hypotenuse and base? So base is 1 minus x square upon hypotenuse is 1. So you can write theta equals to cos inverse 1 minus x square, and the value of theta is sin inverse x. So you can write cos inverse. If we have to write this function in terms of tan, then you can write tan is perpendicular upon base, that is x upon root 1 minus x square. If you have to write the same term in cot, then it becomes 1 minus x square upon x, and so clear. We can do one more conversion. After that you can solve it by yourself. Let's take tan theta. Tan inverse x equals to theta. Then we can get the value of x as tan theta, and we know very well tan theta is perpendicular upon hypotenuse, means perpendicular is x and base is 1. So because of this we can find the value of hypotenuse, that is square root of 1 plus x square. So what we can get, tan inverse x equals to, in terms of sine, what we get, perpendicular upon hypotenuse, that is x upon 1 plus x square. If we have to write in terms of cos, then we get 1 upon 1 plus x square, and so on. Clear? So now before moving further, just pause the video to note it down. Okay, now before moving further, we need to simplify these questions on the basis of these properties which we have studied right now. Okay, so first of all we need to simplify this function. Here it is cos inverse minus 1 by 2. Minus 1 by 2, we can write my 1 by 2 in terms of cos, we can write cos pi by 3. Here pi by 3 comes between the range of cos. What was the range? It's between 0 to pi. It comes between the range, yeah, it's obviously. So cos inverse cancel out this cos, so the final answer is pi by 3. Similarly, we will go with this minus 1 is for tan pi by 4. If we have to remove this negative sign, then what we get? Tan minus pi by 4. Here minus pi by 4 comes between the range of 10. What was the range for 10? It's minus pi by 2 to plus pi by 2, and minus pi by 4 comes between this. So the function is invertible, then tan inverse if tan cancel, we get minus pi by 4. Here sin inverse sin 3 pi by 5. 3 pi by 5. Our limit is minus pi by 2 to plus pi by 2. Is this function comes under the limit? Let's check. Pi is 180 divided by 5, that is something 36 into 3, that is 108. Means the value of this function is approximate 108 degrees Celsius. 108 degrees, sorry. So our limit is minus 90 to plus 90, and here the angle goes up to above than 90 degree. So what we have to do? First we have to convert this, for which the angle comes between this region. So what we can write? It could be written as pi minus 2 pi by 5. We can write, and we know very well sin 180 minus theta, that is sin theta. So we can write it is, now 2 pi by 5 means 36 into 2 72. Now it becomes 72 degree, and 72 degree comes between this range. So now the function is invertible, sin inverse cancel out the sine term, so we get the answer 2 pi by 5. Similarly, we will go with the last function. Here the limit for cos is 0 to pi. If we have to simplify this, this limit goes out of the range. So what we can do? First we have to simplify this by writing this function as, we can write now cos 360 plus theta, that is cos theta, it is in first quadrant, so it shows positive value. Now pi by 6 comes between this range, so we can write cos inverse cos cancel, so the answer is pi by 6. Here these are the answers. Clear? Now we are moving further for these questions. Here sine term is given, here cos inverse is given. If it is if it is sine, then it will be cancel out each other. So now in this question we have to convert this function as a sine. Cos term is base and hypotenuse is given. First, by Pythagoras theorem we need to find out the perpendicular. Now convert this cos function. You can write sine inverse. What is sine? Perpendicular upon hypotenuse. Perpendicular is 4 and hypotenuse is 5. Then sine term cancel out the sine inverse and we get 4 by 5. Similarly, in this question, cos tan inverse 3 by 4. Here it is perpendicular, it is base. So by Pythagoras theorem, we can calculate the value of hypotenuse, that is 5. Here it is cos. So we also write this cos inverse. Cos is base upon hypotenuse, that is 4 upon 5. Now cos term cancel out this, so we get 4 upon 5. Now in this question, it is sine pi by 3 minus. First we have to simplify this term. It is sine inverse and minus 1 by 2 comes in sine at sine 30 degree. And the negative sign, so it will become sine minus pi by 6. So sine cancel out this term. So it is sine pi by 3 minus pi by 6. So when we simplify, we get sine pi by 2 and sine 90 is 1. So it is the answer. And in last question, we know very well the value of sine 2 theta. It is 2 sine theta into cos theta. Here sine inverse 0.8 gave like a theta. Then sine 2 theta, it is 2 sine theta and cos theta. If we need to simplify, then sine inverse cancel out this term, so it will become 0.8 into. Here it is cos, it is sine. First, we need to convert this sine function. Sine function means here it is perpendicular, it is hypotenuse, and if we can find the value of base, we get something 8 square. It is like 6. So what we can write? Cos inverse 6 upon 10. We need to simplify. We get 0.8 into 0.6. So it becomes 0.96. Here it is the answer. So guys, in this video we learned about some properties of inverse trigonometric function. Now further we will continue in our next video. That's all. Thank you.